here are the other 4 trig derivatives that you should know. I'm going to do 2 of them, and I'm going to pause. Well, I'm not going to pause. You should pause when I tell you to and try the other one. So I'm going to do the derivative of tangent. And the way we do the derivative of tangent is by doing the derivative of sine of x over cosine x and using the quotient rule. That's going to be the bottom times the derivative of the top. The derivative of sine is cosine. Minus the top times the derivative of the bottom. The derivative of cosine is negative sine. All divided by the bottom squared. But there's this identity that says, well, look what we have on top, cosine squared x plus sine squared x over cosine squared x, which is equal to, the top is equal to 1. And 1 over cosine is the same as secant, so 1 over cosine squared is the same as secant squared x. So the derivative of tangent of x is equal to secant squared x. So you should take a minute and pause it and try and show that the derivative of cotangent of x is negative cosecant squared of x. All right, unpause it and now watch me do it. So this is going to be the derivative of cosine x over sine of x. Again, using the quotient rule, it's going to be the bottom times the derivative of the top, which is negative sine of x, minus the top times the derivative of the bottom, which is cosine of x, all over the bottom squared. Here we get negative sine squared x minus cosine squared x. If we factor out the negative, we get negative sine squared x plus cosine squared x. I should use an equal sign. All over sine squared x, which is just negative 1 over sine squared x, which is negative cosecant squared x. So the derivative of cotangent x is negative cosecant squared x. And the way I kind of think about it is the derivative of tangent is secant squared x. Put a co in front of it, and the derivative of cotangent is cosecant squared x with a minus sign. All right, now let's do secant and cosecant. I'll do secant, you guys do cosecant. So the derivative of secant is the derivative of 1 over cosine. Let me look something real quick. Here we go. And the derivative of 1 over cosine, well, we're going to use the quotient rule again. It's the bottom times the derivative of the top. But the derivative of 1 is just 0, minus the top times the derivative of the bottom, which is negative sine of x, all over cosine squared x. This ends up being negative positive sine of x over cosine squared x. And while you could leave it like this, nobody does. We break it up as 1 over cosine x times sine x over cosine x. And then we end up writing that as secant x times tangent x. So the derivative of secant x is secant x tangent x. In a similar way, the derivative of cosecant is going to be, well, you should pause it, try to do it yourself. It's going to be almost the same. After you unpause, it's going to be the derivative of 1 over sine, which is going to be bottom times the derivative of the top minus top times the derivative of the bottom, all of the bottom squared, which is equal to negative cosine x over sine squared x, which is equal to negative 1 over sine of x times cosine x over sine of x, which is negative cosecant x times cotangent x. Yeah, we got time. So a couple things I want to say about this because there are some nice patterns. So here's all of our trig derivatives. Oh, if I could be slick. I could have like paused it and then gone and written all the stuff on the other side. That would be super cool. But I didn't. So let's write them all out. So here's all the trig derivatives. This pen is not great. Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. Derivative of tangent x is secant squared x. Another good one. Derivative of, we usually write the reciprocal functions next to each of these functions. So the reciprocal sign is cosecant. Derivative of cosecant x is negative cosecant x cotangent x. Derivative of reciprocal cosine is secant of x is secant x tangent x. And lastly, the derivative of cotangent x is negative cosecant squared x. Okay, 3 things I see here. Thing 1, all of the co-functions, cosine, cosecant, cotangent, have negative derivatives. And all of the not cofunctions have positive derivatives. The second thing I see, which is a little harder to kind of describe, is that tangent and cotangent act the same, right? The derivative of tangent is secant squared x. The derivative of cotangent is cosecant squared x with a minus sign. It also works for secant and cosecant. The derivative of secant of x is secant x tangent x. If we put a co on each of those trig functions, the derivative of cosecant x is cosecant x times cotangent x with a minus sign over. The last thing I want to say, which is what a student showed me one time, is they did this. They do this little picture where they have secant x with a right arrow and then a tangent. Oops, that's not how to do it. Sorry. It was, no, that should be right. Sorry, I know what it is. Secant x goes to secant x, tangent x. And they're at the same sort of thing with cosecant x going to negative cosecant x going to cotangent x. So the way they did this is they say, oh, what's the derivative of secant x? It's secant x times tangent x. What's the derivative of tangent x? It's secant x times secant x, or secant squared x. Works for this too. What's the derivative of cosecant x? It's negative cosecant x times cotangent x. What's the derivative of cotangent x? It's negative cosecant x times cosecant x, or negative cosecant squared x. So there are the trig derivatives in their entirety.